Okay, so today we're going to work on a new type of division. We worked on this actually in Algebra 2, but it is called synthetic division. So we're going to refer back to our long division and our synthetic division now, and we're going to see how do they relate and why do we have this new synthetic division. Are synthetic things really better than the OG stuff? So let's look at our simple example, and we're going to say x squared plus 6x plus 8, and we're going to divide this by x plus 2. Okay, we're working on something called synthetic division. And my goal today is just make sure you understand all the steps so that you can be successful at synthetic division also. So if I'm dividing this, if you guys are good at factoring from Algebra 1 to Algebra 2, we could have wrote, hey, this is x plus 2 and x plus 4, because I can factor x squared plus 6x plus 8. And then you can see that, whoops, darn it. We can divide those out, x plus 4. So here's the big idea. If I end up dividing it, no matter how I do it, in this case factoring, we could end up with a nice term that divides out, and we're left with x plus 4. Now, of course, that's not always the case, and it's not always easy to find the factors. So we have long division. Now, a very simple 8th grade math version of this is if I said 8 divided by 4. Isn't that just 4 times 2 divided by 4? We're left with 2. Maybe I should use 2 instead. But this is the idea. We're just factoring the number, and then we'll see like terms to divide them. Easy way, but not always easy, because sometimes it's hard to factor. So we end up with a long division problem. And then, okay, this is again review, but we have 3 steps of doing that. We have first, we want to match. 2, we want to subtract. Oh, sorry, match, multiply. I'm sorry, I messed up my order. Match, multiply, and then we subtract. So I'm going to do these 3 steps with long division, and hopefully you guys were able to practice this in IXL. We match. So to make x look like x squared, we need to multiply that by x. We multiply down. That's x squared plus 2x. And then our third step was we subtract. I draw a negative sign in the front, and then I do little tag marks on top so you guys can see those. That's a negative x squared and negative 2x, so I don't have to rewrite it. And we end up with 4x plus 8. Now we restart our steps, match, multiply, and subtract. We match. How can I make x look like 4x? We have to multiply by a positive 4. So 4x, multiply 4 times x and 4 times 2. Don't forget the 2. And then we subtract, and we end up with negative 4 minus 4 and 8 minus 8, which is 0. And we get exactly the same answer as we got before. Now, for this type of problem, it's like, it's not hard, and it's something that we've done before, so it's doable. But is there a faster way? Now, a couple of things that we're going to look at is that I repeat writing stuff a lot. Okay, I repeat writing stuff, like I write x squared a lot. I write numbers I want to cancel out anyways a lot. So what if we stop writing those repeat values? And we're going to see, here's our synthetic division now. I'm going to give you a synthetic division. And I'm going to give you guys a step for synthetic division. First thing, a synthetic division, long division has like this L with a line on top. Synthetic division, we're going to draw the line on the bottom. Okay, let me write this problem on the side. X squared plus 6x plus 8, and we're going to divide this by x plus 2. Now here's the thing about synthetic division, hopefully you remember this from last year, is I don't write x squared 6x plus 8. I just write the coefficients, the numbers in front of each of these. How many x squareds do we have? We only have 1. We have, how many x's do we have? We have 6. How many constants do we have? We have 8. You only have to write the front coefficient. It actually saves us a little bit of time. You might think, really, what's the big deal? Again. Now, this next step is not in the book or not in any books. I usually write this myself. I always write the factor I'm trying to divide by in the front, and that's going to be x plus 2. Please take a look at that. X plus 2 is going to help us later on. And then the next step, I'm going to go ahead and say, hey, what number makes this factor go to 0? What will cancel out at x plus 2? If x was negative 2, and that's the key value here. Negative 2 plus 2, that's going to give us the 0 we were hoping for. Okay, so once this is all set up, this is what you should see on your paper. Now here are our steps to follow for synthetic division, and please follow along. Not going to be hard. I'm going to do it once with these numbers. I'm going to erase it and do it again. Okay, so you guys can see it. First step is free. We always add down, add down, add down. That's what we're going to do. Okay, add down, and we're going to multiply up. And I'll show you guys the steps right now. First one's free on me. Bring down the 1. To bring it back up here, we are going to multiply by our key value. And we said the key value was going to be negative 2. So negative 2 times 1 is negative 2. Again, we're going to multiply everything by this negative 2 value because that's our key. Add down. What is 6 minus 2? That's going to be 4. To go back up, we're going to multiply by negative 2. Our key value right here. 4 times negative 2 is negative 8. And we're just going to draw a box here. 8 minus 8 is 0. And our goal here is get 0. Get 0. Because 0 means no remainder. From this last step, we are not done. We have to retranslate our answer. Our answer isn't 1, 4. That's not our answer. When we first started the problem, I copied the 1, 6, and 8. And I want you guys to realize that these are positions. X squared, X, and constant. When we divide out an x, what's x squared divided by x? That's just x left over. We're going to have an x and a constant left over. Let me finish this and I'll answer your questions. We have x plus 4. And that's my final answer. Okay, let me pause here for just a minute. So this other method called synthetic division is, it might not look like it, but it actually is long division. It actually is long division. And I want you guys to see a couple of points that are similar. First thing, you see the 2 and the 8? Don't we have a 2 and 8 right here? Do you see the 6 and the 8? It turns out what we're really doing in synthetic division is we're cutting out the middle guy. We're just focused on this term and this term. And that's the steps we focus on here. So we are doing long division, but I don't write x squared. I don't have to write x squared. I don't have to write 4x because I knew that they were going to cancel out anyways. See, I don't have to worry about the x squared. I don't have to worry about the 4. They were going to cancel out anyways. So we're going to go ahead and do another problem like this, and we're going to see that it's actually really fast to do the synthetic division. So let's do another problem. And here's the problem. It's going to be x cubed plus 2x squared minus 5x minus 6. Now, this is an x cubed problem, and x cubed isn't usually a way for us to, there's no way for us to factor this unless if this was a problem by grouping. And in this case, this is not a grouping problem. But can you think of the 3 factors I could multiply by to get this problem? So I'm going to go ahead and give you guys a head start. I'm going to say go ahead and divide this by, here's my head start, x plus 1. Let's do something easy, x plus 1. So I could write this in long division, and I'll do this in a moment, but let's do synthetic division first. And while you guys are copying synthetic division, I'll go ahead and show you long division. You tell me which one you like better. Our coefficients in the front are going to be 1, 2, negative 5, and negative 6. 1, 2, 5, 1, 2, negative 5, negative 6. Remember, these are positions. This is an x cubed. X cubed. I have 1x cubed. I have 2x squares. I have 1x and I have a constant. So the positions matter. And the reason why synthetic division works is because I'm saying, hey, the first position is going to be x cubed. The second is going to be x squared. The third one, it's just placeholders. I'm going to write my factor in the front. I need x plus 1. That's what I'm trying to divide by. So to write x plus 1, my key is going to be negative 1. Everyone okay with the negative 1 here? All right, first one's on me. And really, this is it for synthetic division. Let's go ahead and start it. Start the machine. Crank it out. First one's free on me. We always bring the first one down because there's nothing to add. We always add down and there's nothing to add. I get up. 1 times negative 1 is negative 1. 2 plus negative 1 is 1. Bring it up. 1 times negative 1 is negative 1. Negative 5 minus 1 is negative 6. Bring it up. Negative 6 times negative 1 is positive 6. All done. Now, how do we use the numbers 1, 1, and negative 6? Is that like 106? What is this? And here's what I want to remind you. Isn't 1, 2, 5, and 6, aren't these just the coefficients of an x cubed, x squared, x, and constant? So when we divide out an x here, that's what we're doing. We go from x cubed to x squared. We have 1x squared plus 1x minus 6. Okay, as you guys look at that problem, I'm going to go ahead and do long division for you, and you tell me how much you like long division versus synthetic division, okay? X cubed plus, you don't need to copy this. I just want to show you guys the steps it would take for me to do long division here. I'm going to do it fast. Okay, done. Take a look here. Do we have the same answer? We do in fact have the same answer, but we did so much more writing. The thing about synthetic division, it's only 2 lines. This is really the only 2 lines of work you need. The third line's the answer already. But please take a look at this crazy part now. That's a speed run, right? I want you guys to notice this part. Remember how we said 2 and negative 1? Where are these numbers from? They're actually from this relationship right there. Negative 5, negative 1, negative 5, negative 1. Negative 6, positive 6, negative 6, positive 6. It takes all the important steps because we know that this was going to cancel out anyways. We know these were going to cancel out anyways. So it just keeps the important part. Who came up with this? I don't know, but man, smart guy. Let me pause. Now, just as a point of where we're going with this, is that starting from x cubed, we now have a way of factoring x cubes. And once we're in x squared mode, we can say, hey, could I factor x squared? 3 times 2, that's 6. And that actually turns out to be my factors. So we could actually have factored down x cubed into its factored form from any exponent now. X to the third, x to the fourth, x to the fifth. If it's factorable, we can find out what the factors are. Okay, let's do another problem. Let's do this again. Okay, let me give you one more problem as we practice this one more time. The problem is going to be x cubed minus 8x squared minus 3x plus 90. And I want you guys to divide this by x plus 3. Again, we could do long division or synthetic division. We're learning synthetic division right now, and I would hopefully you guys agree with me. It's going to be faster. Now, the problem with synthetic division is that you have to remember all these extra rules. Okay, so let's go ahead and set it up. First, let's set up. You have to remember how to set it up. We don't write the x's, we just write the numbers. I have 1x cubed minus 8 minus 3 and plus 90. You don't have to write the plus if you don't want to. You have to remember to write the invisible 1 in front of the x cubed. The way I write this, I'm going to divide this by x plus 3. So I always write the factor on the bottom. It's the way I teach it, so you guys can see what the factor is. And to make this go to 0, my key number is going to be negative 3 here. Super important that you guys see that that's negative 3. All right, let's go ahead and go through the steps of synthetic division. If you guys want to start, you guys can go ahead and start ahead and see if we can meet in the same spot. First one's free on me. We multiply to go up. We end up with negative 3. Add downward. Okay, we're not subtracting. We already made that negative sign clear by flipping that sign originally. That's going to be negative 11. Multiplied by negative 3 becomes a positive 33. This doesn't look like it's going to work. Plus 30. If I multiply to go up, that's going to be negative 90. Oh my gosh, it actually worked. Let's rewrite this. That's x squared minus 11x plus 30. We went from x cubed, drop 1, leaving us x squared. X squared, x, and constant. That's kind of fast, right? I don't think you guys need me to do the long division way, but you guys believe that this is shorter. Okay. Now, this is great, but what if I end up with a remainder? What if I end up with a remainder? So let me give you a problem that's going to end up with a remainder, and we'll do an easy problem first. So just like long division, we might end up with a remainder. We might end up with a remainder here, and let me show you how that looks like. Let's do an easy problem. X squared plus 9x plus 25, and let's divide this by x plus 1. X squared plus 9x plus 25, it's not factorable. Numbers that make up 25 is 5 and 5, and 1 and 25, and none of those combine up to become 9. So I can automatically tell you this isn't factorable, so 1 plus x will not divide cleanly into it. So let's go ahead and write up my synthetic division. I'm going to steal the numbers 1, 9, and 25. I'm trying to divide out x plus 1, so that q would be negative 1. Lightning speed, that's right. First one's free on me. Remember, first one's free on me because I always add down. I always add down. There's nothing to add. It's okay. First one's free on me. Multiply to go up. That's going to be negative 1 because 1 times negative 1 is negative 1. Bring it down. Adding become 8. Multiply to go up becomes negative 8. Adding becomes down becomes 17. Positive 17. Now I'm going to draw a box over my last number. I always draw a box over my last number to remind myself, hey, that's not part of the final answer. That's my remainder. So going from x squared, drop 1, this is x plus 8. What's the remainder? The remainder is plus 17 over x plus 1. Remember, I tried to divide x plus 1 by this, and we couldn't do it. We didn't have x plus 1. We had a remainder of 17. So this is how we have to rewrite our final answer. Now, is this the right answer? Can I double check this? And we actually can. If I say x plus 1 times x plus 1 plus 17 over x plus 1, okay? Oh, this is an 8, I'm sorry. Okay, oops. That's a little ugly. All right, so here's what I'm gonna do. I'm gonna multiply this term by this term here, and then by the front, and then by the back. Because I can multiply binomial by binomial very quickly, I know x plus 1 times x plus 8 is x squared plus 8x plus x plus 8. I multiplied it out. Just rewrite that as x squared plus 9x plus 8. Now, here's a cool trick. X plus 1 times the 17 over x. That leaves me just plus 17. That gives us x squared plus 9x plus 25. And that's our original problem. Okay, just double check that even with the remainder, this is going to take us back to our original answer. Yeah, this is going to be on your test. So make sure when you do synthetic division, it looks just like the way my synthetic division looks. Okay. If it doesn't, you gotta show me where you learned it from. Oh, Mr. Ko, I just did it in my head. You're a liar. Okay.
Hey, Mr. Kohler, what if they're not lying?
No, they're lying. They're lying. They're lying. There's too much stuff to go on in your head.
What if they're like...
They're lying.
What if they're a math prodigy?
There are no math
Look at that,
prodigies in this
mister.
class. You're liars.
Yeah, Mr. Ko, you really...
Hey, I believe in human ability. I do. But you would demonstrate that ability throughout the whole year. You don't just all of a sudden, oh man, I'm a genius at synthetic division. I don't have to do any math in my head anymore. You're lying. It's cool. Just learn it. It takes you like, what, 10 minutes to learn this process? Okay. All right. I'm going to stop here now, and this is it. This is really the lesson. So if you have any questions, you guys can continue to ask questions, and I'll be here.